Hello and welcome to this lecture on complex integration. And in this video, we are going to talk about contour integration of type 1. So, type 1 will consist of cos and sin theta. So, the function of cos and sin theta and the integral limits will be of 0 to 2 pi. So, then we have to convert this function in the terms of z by using these conversions. That's all. Okay. So, these are the procedures. First, we want to identify the type and we want to convert this cos and sin theta in the form of z by using those conversion. And then we want to find the poles. If the poles are of order 1, then we go for the formula. The limit z tends to a, z minus a, f of z when the pole of order 1. Okay, we will use this formula to find the residue. If it is of pole of order more than 1, that is 2 3 4, now we will use this formula to find the residue. After finding those residue, we will apply in the Cauchy residue theorem, and at last we will evaluate this problem. That's all. Throughout this, we will consider the curve as mod z equal to 1. Okay, and here they asked to evaluate the integral using contour integration, and here the function is 1 by 13 plus 5 sin theta. So clearly it belongs to type 1 because the integral limit is of 0 to 2 pi, and here this function involves sin theta, so it is of type 1. So we want to convert the d theta into z and sin theta into z form. So here we have a sin theta can be of 1 by 2i and z minus 1 by z, and d theta can be of dz by iz. So on the next step, what we will do, 0 to 2 pi and d theta, I may write this function as 13 plus 5 sin theta and d theta. So it will be of 0 to 2 pi. I may substitute the value 13 plus 5 1 by 2i into z minus 1 by z, and dz theta can be written dz by iz. So here this will be of integral 0 to 2 pi 1 divided by 13 plus 5 into, if I multiply with this term 2i, it becomes z square minus 1 into dz by iz. So then it can be written as 0 to 2 pi. It will be of 26 iz plus 5 z square minus 5 divided by 2 iz 1 into dz by iz. So on the next step, it can be written as 2 iz integral 0 to 2 pi 2 iz into 5z square plus 26 iz minus 5 into dz. Just see this, the same. Here it will be of iz. So this can be simplified as iz will get cancelled, and 2 by 5z square plus 26 iz minus 5 dz. Okay, so now we have converted all in theta terms to z. So we may consider the function f of z equal to 2 by 5z square plus 26 iz minus 5. Okay, so now we want to find the poles. So to find the poles, we will equate the denominator part to 0. So 5z square plus 26 iz minus 5 equal to 0. We will equate this by using quadratic formula. So 5 b will be of 26, I c will be minus 5. We have a formula minus b plus or minus square root of b square minus 4ac by 2a. So when we apply this, b will be 26i plus or minus square root of b square 26i square minus 1. So minus into minus 1, we may write this as 676, 26 at 676. So 676 and minus 4, a will be 5 and here minus 5 divided by 2 into 5. So then 26i plus or minus square root of minus 676 plus 100, then 10. Then minus 26i plus or minus 576 divided by 10. So we know that 24 24s are 576. So it can be written as minus 26i plus or minus square root of minus 24 into 24 divided by 10. On the next step, minus 26i plus or minus I into 24 divided by 10. So from this we may write z1 as minus 26i plus 24i divided by 10, and z2 will be of minus 26i minus 24i divided by 10. So here minus 2 by 10, 2i by 10. So minus 1 minus I by 5. So here it will be minus 50i by 10. So we will get minus 5i. So this will be Z1, this will be Z2. Now we want to check whether these poles lie inside the given unit circle. So we may take Z1 first. So Z1 will be minus 5i by 5. So the square root of I square will be 1. I square minus 1, minus already is there. So 1 by 25. So 1 by 5. Definitely it will be less than 1. And modulus of Z2. If I take this square root of minus I, it will be of 25. 5 is 25. I square it will be minus 1. Again minus it multiplied. We will get square root of 25. 5. It is greater than 1. So Z1 lies inside C. Here Z2 lies outside C. So we will find the residue for Z1 alone. So the formula will be limit Z tends to A, Z minus A, then f of Z. Here A will be Z1. Therefore, residue equal to Z1, f of Z equal to limit Z tends to Z1, Z minus Z1, then our f of Z. So now we have find the poles, and of course we want to write the f of Z. Simply, what is our f of Z? 2 by 5 Z square. So just see how we may write this. Z minus Z1, Z minus Z2. Yes, whether it is right, we may check this. Just see our f of Z is 2 by Z minus Z1. If I choose this, whether it will be equal to 2 divided by, what is the function we consider? 5Z square. 5Z square. 5Z square plus 26 iz minus 5. Whether it is equal or not, we may check this. Here if I substitute the values of z1, it will be of minus I by 5, then here minus 5i. Just see, you just multiply these two factors. What you will get here? I may simplify this. I5 is set by 5i. Okay, and here I will get the 5z square plus 25i plus 25iz 25iz plus iz minus 5 by 5. Just see here, when I multiply these factors, I am getting the value as 2 by 5z square plus 26iz minus 5 divided by 5. So I'm getting this 5 as a excess value. So what we want to do hereafter, I may take this 5 into z minus z1 and z minus z2. So therefore our f of z will be 5 into z plus I by 5 into z plus 5i. So this is our f of z. This is our f of z function. Okay, so if I do this calculation, I have to multiply by 5. Okay, now it is equal. So our f of z will be 2 by 5 into this term. So what we want to do on the next step while finding the residue, so while finding the residue z equal to z1, f of z equal to limit z tends to z1, z minus z1, 1 by 5 into z minus z1 into z minus z2. So these two factors will get cancelled. So limit z tends to z1, 1 by 5 into z minus z2. So limit, while on the next step we will substitute the z value. So 5 into z1 minus z2. So we know that our z1 value will be minus I by 5. Here z2 will be minus 5i, so it gets 5i. So on the next 5 into, here it is I, so 5 minus 5 plus 25i. So on the next step 5 will get cancelled, so 24i. So this is our residue when z equal to z1. So we find the residue part. So what will be the next? We have to apply in the Cauchy residue theorem. So what's that? Integral over c f of z dz will be equal to 2 pi I into sum of residue. So we find that we find two poles. Out of that, one pole lies inside the circle. So we find the residue for that alone. So finally, 2 pi I into 1 by 24i. Okay. So I will get cancelled, and then we have missed the function. Here the function is 2 by, yeah. So here we have to multiply by 2. Sorry, I have missed this 2 value. Or also we can multiply at last also. So here it will be of, if I cancel, it will be 12. So at last I will get the values pi by 6. Okay. So finally, integral over 0 to 2 pi d theta by 13 plus 5 sin theta will be pi by 6.